Now we can talk about the third principle, that is Liskov's substitution principle. Now this principle states that a client should be able to use the class and its derived classes indistinguishably. If I am using a class A or its child classes B, C, D, I as a client do not need to distinguish between A, B, C, D. I should be able to simply use the classes as they are. Now let's take a simple example. We have the payment method, which is a class, and it implements the process method. We have the credit card payment class. We have gift card payment class. Both of them inherit from the payment method. Now, in this case, the gift card payment class in the process function, there is a statement if amount is greater than 100, it raises a value error saying cannot process gift card payments over $100. And then we have another function which is make payment. This make payment function takes in the payment method as a class and the amount, and then calls the process method of this payment method class. Now, for example, a valid usage for the credit card is credit card payment, and then we make the payment using a credit card for amount 150. Same as with gift card, make payment, gift card, and 150. Now this is going to raise an error because we have a limitation here. If the amount is greater than 100, we need to raise an error. Now I would encourage you all to please pause here and take a moment to find out some limitations of this code. All right, and now that we are back here, let's go through some limitations that I was able to figure out. The first one is magic numbers. This magic number 100 is introduced in the gift card payment class. This could have been a variable. The second thing, which is a logical flaw now, and it's a subtle thing though. The subclass deviates from the contract. Now, for example, in the abstract base class, we do not have any condition on the amount. But in the gift card payment class, in the process method, we have a condition on the amount. What this means is that for some reason, the gift card payment will not work according to the payment method because it cannot process amounts which are greater than $100. And while this may seem a bit logical, imagine that the gift card payment is owned by some other team. And now we get a method. And now we get an error saying cannot process gift card payments over $100. There would be fights between the teams because the contracts have been broken here. What me as a client in this case would expect is the process class to run flawlessly, and it should be able to process any and all amounts and raise an understandable error. So now let's try to apply this principle to this class. We start by creating an abstract base class for the payment method. Now this interface of payment method should implement the process function that takes in an amount. And now the credit card payment will inherit from the payment method. Now the gift card payment will also inherit from the payment method. And now in this class, in the gift card payment class, we will instantiate it with a balance variable. And now in the process method, we can check for this condition if the amount is greater than the balance itself. That is, say we are trying to spend $120, but we only have a $100 gift card, then this payment method should now raise an exception. And this is what it does. It now raises a much more better exception that is understandable to me, saying insufficient balance, available balance is only self.balance. The rest of the things stay exactly the same. And this is the value error that we raise. Now, what has changed? There are no more surprises. Both the classes, the gift card payment and the credit card payment, can now be used interchangeably, and they exhibit more or less the same behavior. And the second thing is we are also using the abstract based classes now to inherit from the payment method class. Is this the best way? I think in this one, we'll have to ask ourselves if the overhead is worth it. Again, in this case, if the system is rarely going to change, this might add some more overhead for us rather than writing a straightforward code base.